Hey, good morning. We are going to do problems 1.1 and 1.2 this morning. We're talking about walking rates. There's some background information that might be helpful, which is to know this formula. Distance equals rate times time. The D is distance, the R is rate, the T is time. You can also rearrange this by that distance over rate equals time. Distance over time equals rate. So if you need to solve, if you want to figure out the distance, you can use that formula. If you want to figure out the rate, you can use that formula. And if you want to figure out the time, you can use that formula. So we're going to try some of these problems. I'm going to leave that here for reference. And the first part asks you to time how long it takes you to walk 10 meters. It's approximately 33 feet. If you do not have meter sticks at home, do your best to measure how long it takes you to go approximately 10 meters. I am going to use the rate for not walking, running. I'm going to use Usain Bolt, who's like the fastest dude in the world. And his time for the 100-meter dash, and hold on, let me just double check, fact check myself here. Uh, 9.58 seconds. So he runs 100 meters in 9.58 seconds. So what you need to do for part A here, it says, what is your walking rate in meters per second? So in my example, I have 100 meters in 9.58 seconds, and I would divide those, which is going to get me, see, where's my calculator? Here you are. Let's see, 100 divided by 9.58. Oops, 100. I did 6.58. 100 divided by 9.58 is 10.43-ish. So I'm actually going to round that up and pretend that I'm faster than Usain Bolt and go 10.5 meters per second. You may remember some of this from when you did conversions in science class. So that's how I got it. I got 10.5 meters per second. For you, you're going to have something a little bit different because you're going to have 10 meters, not 100, and it's going to be over whatever time you got. So 10 divided by however many seconds it took you should give you your speed in meters per second. And this is speed. Or walking rate, as they say it in the book. So that's how you're going to figure out part A. Will be that way. Now for part B, it says, assume you continue to walk at this constant rate. And it says, how long would it take you to walk 500 meters? In this case, we're looking for time, right? We know your rate and we know the distance that you want to go. So we can look back. My lighting is not great. We can look back at this and we can say, okay, what we're looking for is time. The equation that has time by itself is that guy. So in order to find time, we take distance, keep doing this backwards, distance divided by rate. So in this case, in my case, because I'm talking about Usain Bolt going 10.5 meters, that would be his rate. And the distance is 500 meters. So I do 500 divided by 10.5 because I'm obviously faster than Usain Bolt. So 500, and I, as you guys probably remember, like to write my division as a fraction. 500 over 10.5 means 500 divided by 10.5. 500 divided by 10.5 equals 47.619. So you can round. I'm going to say 47.6 seconds. And when you are writing your answers to these, make sure that you're answering the actual question, right? It says, how long would it take you to walk 500 meters? So your answer should say some number of seconds. And we're dealing in meters and seconds as our unit. So my answer for part B and then number 1 is going to be 47.6 seconds. And this is how I would expect you to show your work, right? This is the distance, this is the rate, and that equals the time. And then it asks how far, for part 2, how far could you walk in 30 seconds, in 10 minutes, and in 1 hour? So if we're looking for distance, we're using this top formula, rate times time. So this is number 2, distance equals rate times time. So for 30 seconds, I'm going to go distance equals 10.5 times 30, which equals 10.5 times 30 equals 315. And now we're talking distance, so we should have the units of meters. Now, in this next one, distance equals 10.5 times, and instead of 30 seconds, it's saying 10 minutes. But, this is important, our speed is in meters per second, so we actually would have to convert that 10 minutes into seconds before you do your multiplication. So I'm just going to go and Google. I mean, you could do the math because maybe you remember how to do that conversion from science, but you do not have to. You can Google how many seconds in 10 minutes, which is going to be 6 times 10 or 600, but it's okay to look it up. I promise. So 600 seconds would be 10 minutes. So then I would do 10.5 times 600. 10.5 times 600 equals 6,300. 6,300 meters. Now, remember, you're going to be getting different numbers than me because your rate should be different. Your rate should be your own rate, right? Okay, so back up. If you cannot, for whatever reason, you do not have the right measuring tools or the right space, you can use 3. So if you are not able to measure your own walking rate, use 3 as your walking rate. So for this is 30 seconds, this is 10 minutes, and then the next part says 1 hour. So again, we can just look it up. How many seconds in 1 hour? 3,600, right? 60 minutes times 60 seconds. So our distance would equal 10.5, which is my rate, times 3,600. And then I'm going to use a calculator. 10.5 times 3,600 is 37,800. Meters. Like that. So remember to use units. So this is numbers 1 and 2 for part B. And then part 3 says, or number 3 for part B says, describe in words the distance in meters you could walk in a given number of seconds. And basically, what they're trying to get you to say is you would walk, the number of meters would be equal to the rate times the number of seconds. That's really what they're trying to get. They're actually trying to get you to figure out that formula that I gave you at the very beginning on your own. But yay, I gave it to you. Distance equals rate times time. So when they're asking you to write that, you can just write out in words, distance is equal to your rate times the number of seconds. So your walking rate in meters per second times the number of seconds. And then number 4 says write an equation that represents the distance in meters that you can walk in t seconds if you maintain this pace. So we're still going for the same formula, except instead we are replacing the r with your own personal rate. So in my case, or me, magical me that's faster than Usain Bolt, it would be distance equals 10.5 t. So distance equals 10.5 t would be the equation that we're looking for number 4. And again, your equation will be different because that instead of 10.5, you would have your own rate. And then it says, for number 5, it says use the equation to predict the distance you would walk in 45 seconds. So just like these guys, right, we're plugging in a time to figure out a distance. In this case, what you're going to want to do is show that you use the equation. So D equals 10.5 times 45. D equals, let's see, and totally cool to use a calculator. I don't want you to be multiplying all these fractions out. It takes a lot of time, and that's not really the skill we're going for. So 10.5 times 45 equals 472.5. 472.5. And again, this is distance, so we should use the units of meters. And this is number 5. So for this 1.1, it should look similar like that. You should show your work, but your numbers are going to be a little different because your rate should be different. You should be taking your actual rate, and you can round to the nearest tenth because that will make the math a little bit easier. I think I said at the beginning of this that we were doing 1.1 and 1.2, but I think I'm going to make 1.2 a separate video. So that was 1.1, and stay tuned for 1.2.